All right, go drive.
All right, so today we're going to be talking about reactjs, and let's move on. So a little history. So before we actually used reactjs, we kind of had, especially related to the map. So Tony and I work on the map. We kind of had two pages. We had one page that was kind of what we would call a single page app, and that is the page on the left. It was highly interactive. You could search for different regions. You could filter things. You could drill down and try to find the home that you're looking for. But on the right side, what we had is another page, and this page was specifically built for Google. We get a lot of our traffic from Google, so SEO is like search engine optimization is like a really big thing that we try to promote and like instill in our pages. And so what we did is we actually created the second page that was not interactive at all, pretty much. It's pretty much a static list of links that would go to active listings, homes that come on the market, go off the market, etc. And the problem with this is that, you know, when people search on Google and they try to find real estate, let's say in San Francisco, they don't get the great single-page app version because what we do is we tell Google, here's all our pages, and it's actually the one on the right, and so they would land on the page on the right. And we had a really high bounce rate, so we wanted to kind of bring these two pages together. Now, to also kind of frame the problem about this as well is that we were on a JavaScript framework that I'm not sure that anyone might know about it. Maybe they do. It's called Dojo. It's a little bit older. At the time, it was good. But as years have gone, it doesn't have as much popularity, definitely not as much as reactjs. And we wanted to be really careful about moving to a different JavaScript framework. We didn't want to just jump ship, switch to Angular or anything like that. So we wanted to make sure that we made the right choice. We're kind of looking for what I call like the holy grail of a system that would kind of hit our key metric of building out a page that Google can crawl. So we tried to figure out our SEO strategy using the existing framework that we had. So one attempt that we did was actually try to use Phantom.js, which is great for like doing testing. You know, it works well for that. But what we did is Google has a mechanism that you tell it, please call us back on this different URL, and we will render that page for you. And we set it up so that Phantom.js, we had like a bunch of Phantom servers, and what we would do is build that page, and everything including the DOM, build it up in memory, and then spit out the HTML that that page had. Now, Dojo was not meant to do this. It had a lot of gremlins in the system, so it kind of crashed a lot. In fact, I think we had like a daemon that would restart the Phantom servers pretty much every 5 minutes. This was not ideal. And then, you know, God forbid that there's an actual error in there. Debugging it was a pain in the butt because we did not have Phantom set up, like this whole setup internally on our dev boxes. So we're kind of like looking around for the next thing. Lo and behold, 2014, reactjs comes out. And it seemed like it might be the thing that would help build our pages and solve all our problems. So we started out small. We picked one of the components that was kind of highly dynamic. It's our autocomplete box. And just tried to see how we felt about it, see how like, we use it. And so the autocomplete box is, you know, as you type, the results change. It has a lot of state or props to it, so that the DOM nodes had to be maintained if you were going to do this in kind of a jQuery or Dojo setup. You had to maintain like, oh, I already had this one in here, I'm going to reuse that one because I don't want to keep rebuilding DOM nodes. And so we redid this in React, and the amount of code was significantly less. So it kind of, and we didn't use anything fancy on this one. We didn't have any stores or any fluxes, all on the browser side. We wanted to just try it out first. So, and then we did it, and next thing you know, we loved it. It was a lot easier. It was something that seemed like we could try to bring this to the server side. So we kind of wanted to take it to the next level. And what we did is we created a sort of a prototype setup. You might have heard the term isomorphic, or another word for it is universal JavaScript. We wanted to write the views only once, but we wanted those views to get rendered on the server side, and then be able to use the same ones on the client side. So what we did is we took one of our pages, the what we call the Regional Agent Directory page, I think, or RADP, and converted it using an idea and a system setup that we thought might work out. So what we did is we set up, use Node, set up a system that would take those views, those reactjs components, and render them server-side, and spit it out, and then let the client-side rebind to the same exact views that were used on the server, and the page worked. And the results were great, actually. Being able to have the HTML built on the server side, and then only bind to it once it comes on the client, was highly performant, and so the speed was great. So next thing we did is we kind of looked around and tried to figure out all the major issues and figure out all the different key features that we wanted to build out so we can bring it to the rest of the company. So, as you can tell, we love this even more. So, without further ado again, we're kind of introducing today something that we call React Server. It is available today. We actually just published a blog post about this. But I'm kind of going to go over I'm going to go over the main features of this thing, and Tony's actually going to go over a demo using some of the key features. But I'd like to explain some of them as these are the main things that we want to make sure we nailed correctly with React Server. So one of the things is speed. We wanted to make sure that the pages were rendered quickly, that was a given. We also wanted to make sure that the page returned as fast as possible. So at our company, we kind of think about time to first byte as being a very big deal. We wanted to make sure that the head and all the JavaScripts, all the CSS are returned immediately so the browser can start showing the page. So that's built into React Server. It has mechanisms for you allowed to send down the head quickly, and so that the browser can start churning on the page. Another aspect of it, which is kind of was done in the prototype, is universal JavaScript. So being able to have the same views that are rendered on the server would be the same ones that are used on the client. And what that does, it enables us to have client-side transitions. So the browser, instead of having to go contact the server for a whole new page, is able to say, like, I know about the different routes, I know the different pages that I might navigate to that are within my domain, and is able to only just fetch the JavaScript, the CSS, and the data required to render that page. Some other things about it is that we want to make sure, so actually at Redfin, where we have really long pages on some of the parts of our website, and we want to make sure that user perceived performance is really high. So we want the top of the fold, part of the page that would show up in your window of your computer, to come up immediately. But things like a footer or like content that's really far down the page can come in whenever it's ready. So React Server has mechanisms that you're able to specify sections of components that can come in whenever they're ready. And what that allows us to do is make it seem like a user perceived performance, even though the page might take a couple seconds to load, is almost instantaneous. Another key feature is data caching. So what we want to be able to do is all the calls for API, for like getting the data to render the components, we want to make sure that when the Node server made those calls, that the browser doesn't have to remake them. So what we do is we take the API calls we made, put it in a big JSON blob, and associate it with the component, and then send it down to the browser. So when the browser bootstraps up the JavaScript, it doesn't have to go make the API calls again. It just has all the data right there, and just can re-render the tree as is. And then lastly, and definitely not least, want to make sure that it is SEO friendly. So just by the nature of React Server, it renders it server side. Google, now what we can do is combine both of our major pages into one, which we have done actually. And so that now Google can crawl our page that all users use and see all the listings as well. So next up, I'm going to have Tony kind of go through some of the key features of React Server. Talk about that.
Whoa. Works. Okay. Let's kick off with npm start. And I'll kind of go over how to set up a page in React Server and what some of the features are we have for performance and SEO. So to tell React Server that, hey, we have some pages to set up, you need to provide a route file. And basically what this does is you provide some URL here, which is some path, and you tell it what page to render. And as you can see here, there are 3 sets of URLs that we render for each of the demos. So let's just go into the first one here, which is called index. Okay? And as you can see here, the page size is really minimal. All you have to do is define the minimum amount of component that you need to render. And get element basically tells you, what am I rendering and what am I supposed to show. So actually, let's start with some div that says, welcome to React server. And, okay, you gotta turn it down. Okay, and then we can go to localhost demo/1. There you go. That's basically our first page. Okay, so there are a lot of things that you can return in get elements, and in particular, a common use case we have is returning an array of stuff. So imagine you have some component A that comes in, and you have some B that comes in. And what React Server will do is it goes through a list and renders them out sequentially in order, and you'll see them show up in the order that you want them to be. And in particular, sometimes something might not come back at around the same time. For example, you have some B that's waiting on some server call that takes like 10 seconds. And then you have a really static component A, maybe like a header or something that comes down immediately. So I want to kind of showcase what React Server does when it sees like multiple promises coming back at different times. So in order to do that, let me uncomment out this util. And what this does is we pull in queue here, and queue is some tool that we use to make deferred and promises. And we'll pass into this method some time, and this will create a deferred object right here. And this deferred object will be resolved after some timeout that's passing as an argument. And when this is resolved, it'll be resolved with some component. And this is basically a component that displays however time that's passed in. And finally, this method returns a promise. Okay. So what we want to do here is return a chain of promises that will be resolved at like some fixed intervals to demo this. Okay. So let's start with some times in milliseconds. That, and you map them out. Okay. Winter says it's fine. Okay. Sorry. Okay. So effectively, what this does is it transforms an array of times into a chain of promises, and what I expect to see is a sequential list of things coming back at 1 second intervals apart. So let's go to the same page. Let's refresh. There you go. Things are showing up. Good. Okay, let's take a closer look at the network tab and see how React Server handles this kind of request. Let's refresh the page. Now, there's a lot of interesting things here that we can note. So first off, this first request is to the React Server, and you can see that content downloading takes 4 seconds, which is expected because that is blocked by however long it takes to return the slowest element, which is timed at 4,000 milliseconds. But more interesting to note is that time first byte is around 10 milliseconds, and this is not blocked by any get element or slow element. So this is super important because, as I stressed earlier, the head is super important because it blocks the rest of the page. So by allowing the head to come down as early as possible, the browser can then start downloading certain things that the page needs to get going. For example, the second and third request are actually JavaScript bundles that the page is needed to get going, and see that they happen quite early, instead of way later, like 4 seconds later. Cool. So now you see how React Server tries to optimize on single page performance. But Rob also talked about earlier, there's a thing called client transition. And what this does is React kind of optimizes on page-to-page transitions within the React Server. So to demo this, I have the second set of URL. So this is client transition, and this URL says, I have demo2/some value. And this value is some string or some number that we capture. For example, it can be demo2/0. And then what we want to see is going from what it looks like in the browser, going from /0 to /1 and /2, and see how the history is managed there, and what kind of optimizations React Server would do. So let's go into that. Okay. So React Server allows you access to a request. So you grab it like so, and get a request. And then from the request, you grab routes. And this is some object with all the values that you would capture from the URL. So here we have a value, which is captured right here. Okay. So what we want to do is provide a link tag that goes to the URL, but where the value is incremented by 1. So in order to hook into React Server's client transition, you're pulling the link element. So let's just write out a React component that kind of provides a link component with a URL that goes to the next value. So, help test. Here you're passing a value as a prop. And here you return a link element where you specify the path. And the path would be basically the same path except that the value will be incremented by 1. So we do demo 2. Press an int. Close it. And might as well just also include a value for clarity. Close the link tag. Okay. And then here you're just returning this link tag for the test. Okay. Just refresh this real quick. So what this does is, if I go to demo2/0, I'll see 0 show up on the page, and there'll be a link tag that says, oh, let me go to the /1 because of this route, and then we'll see how it looks like on the browser, on the client side. Okay. So demo2/0, and there you go, 0 is here. If you hover over this, the href will say 1. You can't really see that, but it's true. So if you click on it, yeah, there you go, it goes to 1, right? And the URL also changes as you press on this. And most importantly, let me just clear the network tab. And notice that if you click on this, nothing really happens in the network tab. And this is client-side transition. What happens is that React knows about the destination URL, and it goes through a route and say, oh, actually, this page is already rendered, so I don't need to download all the static like JavaScript files that goes along with the page. So nothing is really requested to a server. And let's look at the history stack here. You see, oh, actually the history is followed very nicely here. The number incremented correctly. Let me just click on any of these, play around with history. And there you go, there's no network request going out. And React Server is handling this client navigation, like history management, replace state, and pop state very nicely internally, so that you don't have to worry about it. And all of this is made possible by the fact that this is isomorphic, which Rob alluded to earlier, and meaning the same piece of code is being run on the server side and the client side. So the client is saying that, oh, actually, much work can be done on my side, so I don't need to make a request to the server. And to kind of demonstrate this isomorphism, we have this third demo. And what we want to do here is, let's render a component that looks different on the client side and the server side. Okay? So what we want to do here is, well, the approach is to have an initial state that has some string that will be displayed in the render cycle. And then on the client side, we want to set the state so that that string will look different and see the change on the client side. So what we want to do here is define the client class. And then we need a constructor here because we need to set a state. And this will just be some value. Server. Okay. And in the render, we probably just want to display that string. And now here comes the part where it's like, how do I make the client act a little bit differently from what the server does? And in fact, you can hook on to React's lifecycle, which is in component in mount. And you notice that component in mount only happens once, and it only happens once on the client side. So this is how we allow our component to act a little bit differently when it's in the server and on the client side. So in component in mount, we want to just say, let's set state, and change this value to iron. Close it. Let's return this. Okay. So what you expect to see here is the raw server result will say server, and then sometimes later the client will wake up, the JavaScript will start executing, and it'll say, oh, actually, I'm in component mount, and the text will change. It'll come quicker. Let's see this. Catch it? All right, let's save it. So this is a raw server and the results we see. And if you let JavaScript kick in again, you see the config is in the client side. And this demonstrates the fact that this is the same code running on the server and client side, because essentially what happens is on the server side, React server runs through these code and sends out these elements. And on the client side, once it wakes up, JavaScript starts executing, the same piece of code is being run through, and the React component is being re-rendered onto the same DOM. And then it runs through a lifecycle and it sees component amount, and it's saying, oh, let me set state, and then this whole thing re-renders saying client. Yeah, so that's that for the demo. Let's go back to presentation. So where are we now? We came a long way since when we first ventured onto this, starting with small components and then moving on to single-page applications, prototyping with React Server. And over the past year and a half, we have ported our major pages into React and React Server at Redfin. In particular, these are all the most highly trafficked user-facing pages, which is a map page that Rob and I worked on, a home details page, and a home page. So to put at scale, there's around 10 to the third requests coming in per second on 192 cores. This is just to put at scale that React Server is able to handle this amount of requests on this production environment with all these users hitting. So yeah, to wrap it up, thank you all for coming. We just announced this blog post right here about React Server. And our repo is posted here. My server demo is here. And I think this presentation will be posted, demo posted. And yeah, thank you all for coming.